Okay, welcome back. Yeah, welcome back. I'm going to talk to you about suvat equations, but my preferred title is kinematics. It's a word that's going out of fashion these days, which is a shame because it sounds nicer. Kinematics is an actual word, suvat isn't. Kinematics is the study of motion of a particle, so consider its speed, velocity, acceleration, displacement, the path that it follows. Okay, and from this we can get some equations that could be useful to help us solve some problems. What I'm going to do is I'm going to show you these two equations here to begin with, and then show you the lettering that we use. Okay, so this is an equation that you ought to be familiar with. Acceleration is change in velocity divided by change in time. Okay, and if you're with me when I went over this question here, okay, you recall that to find the acceleration, okay, we looked at the gradients, okay, the change in velocity over change in time. So that's just essentially a reminder there for you. Now, in terms of the letters that we use, okay, we use U to represent an initial velocity. So that is the velocity at the beginning of when time starts, t equals 0 normally. And V we use to represent the final velocity. That is the velocity at the end. Okay, so going back to this, in this case, U would have been 0 meters per second, and V would have been 15 meters per second. Sometimes I distinguish between my U's and V's by that's a clear vertex on my letter, okay, and that's a clear bit coming down. Okay, otherwise my handwriting, yes, I know it's not the best, but there you go. Here, if we write the lettering, then change in velocity must be the difference between these. Okay, but we do it in this particular order because it's an acceleration. If it's a positive acceleration, that means they're speeding up, so V minus U gives a positive value. If they're slowing down, you'll get a negative answer, of course. That's because V will be smaller than U. Okay, so so the order there is quite important. So V minus U divided by T. In letters, that's what this equation actually is. A equals V minus U over T. And what I'm going to do is I'm just going to rearrange that for you, and we get this. Our first of the suvat equations. Okay, let me just show you how that's done. Okay, so from this, if I put the t onto that side, I've got AT is equal to V minus U, and then putting the U onto this side, of course we've got U plus AT is equal to V, which is written like that. V equals U plus AT. Okay, now why are they called suvat equations? Why are they called suvat equations? It's simply because of the lettering that we use. So S for displacement, D we don't generally use. Remember, displacement is different from distance. Okay, displacement means total distance from a particular point. U, as I've mentioned, for initial velocity, V for final velocity, A acceleration, T for time. That's the lettering we use. Okay, hence suvat. Okay, like I said, I hate that word, but other people tend to use it, so I find I'm using it as well. Okay. Here, different equation. Displacement is average velocity multiplied by time, taking you back to this. Okay, if you're with me when we worked out the distance travelled in this part of the journey for 20 seconds, what we did was we did 20 multiplied by 15, and that gave us 300 meters, of course. Just a demonstration that the total displacement can be found by doing the velocity multiplied by the time. Or if you've got a triangle, remember what we do is we halve the base multiplied by the height to get 75. Okay, here to here, the average velocity is the average between 0 and 15. Okay, divided by 2. So just a demonstration there, a reminder of how to get the formula. Okay, in terms of the lettering, okay, the average velocity will be the sum of the initial and final velocity. Okay, divided by 2. That's how we find our average there. I'm talking about mean average, of course. Yeah, that sort of goes without saying, but I realise as a mathematician I should specify which average, the mean. Okay, also the median in this case. You notice, but yeah. And you can write it like this as well if you wish. Okay, which one do you prefer? Do you prefer this one or this one? Obviously, I prefer this one because I put that in type lettering. Okay, but some people like that one. I prefer this one because you can see the fraction clearly as a distinct number, half. Okay. Those are our first two equations. Now I'm going to show you how we can use those to get the other equations, okay, the other formulae. So they can be done quite easily. You can substitute equation 1 into equation 2, rearrange to get that. Let me show you how that's done. So equation 2, I'm going to rewrite S equals a half U plus, and I'm going to substitute equation 1 in there. So rather than write V, I'm going to write U plus AT plus AT, and then close the bracket T. So that's equation 2 with equation 1 substituted in. Let's just simplify that a little bit. So 2U plus AT multiplied by T, and then can you see when you expand, you've got UT, and then that's with plus half AT squared. So S equals UT plus half AT squared. Okay, so that's the third. I'm not numbering all of these. I've just put numbers 1 and 2 because it makes it easier to write here what the method is for dividing the others. Okay. Now I'm going to rearrange equation 1 to get this. Can you see how that one's done? Okay, so rearranging to make T the subject. So you'd put U onto this side to get V minus U is equal to AT, and then that would come out nice, isn't it? And then divide by A to get T equals V minus U over A. So that's that one there. And then if you substitute this into equation 2 again, you're going to get another of the formula. Okay, you'll get this one. Okay, let me just show you the working on that. So coming to this again, you've got a half U plus V, and then multiplied by T, which you've got is this, V minus U over A. Now you can notice I've written it like that, just because it's a little bit easy to see what's going on. So this is a situation when you can write the U plus V over 2, the same as that, and then you've got here the V minus U over A. Okay. Now when you're simplifying this, you can put the 2A together like this. So you've got S equals U plus V minus U over 2A. And I'm sorry, this is not ideal, but I'm just working with the board space that I've got. What I'm going to do is I'm going to put the 2A onto that side first of all. Okay, so I've got 2AS is equal to U plus V minus U. And all I'm going to do is I'm going to rewrite the U plus V as V plus U, and then V minus U like that. Okay? And the reason I've just switched the order around is quite simply because you can then see it's a difference of 2 squares, which makes it a little bit easier to expand the brackets. So that's going to be V squared minus U squared, expand the brackets, and then put the U squared onto that side, you get this. V squared equals U squared plus 2AS. Okay? And that's that one. Okay? I'm going to stop there before I go into the next one, because what I'll say is that from what you see on the screen here, those are enough. Okay, I never use that one personally. Okay, I'm going to show it to you because obviously you can use it, but I never ever use that one. Okay, these ones are enough to solve any problem that's given to you. But what I will do for completism, I will show you how to get to the last one. If you rearrange equation 1 again, you can get U equals V minus AT. That's hopefully kind of obvious. Just put the AT into that side, you get V minus AT is equal to U. And if you then substitute this one into equation 2, you get the last one. Let me just show you how that works. So equation 2, S, there we go, S is equal to a half, what have I got, U, so that's V minus AT plus V multiplied by T, so that's a half, and then that's going to be 2V minus AT times by T, expand the brackets, so that's going to be VT, and then subtract half AT squared, there we go, S equals VT minus half AT squared. Okay, but as I said, you don't actually need to use this one. Okay, those are our suvat formulae. Okay? What I'm going to do is, on a separate video, because this one's going on for too long now, I'm going to give you some examples of how these work. Okay, I'm going to stand back so you can take a screenshot if you wish. There you go. Thanks for watching. I'll see you again.